Hello guys, today I'm gonna show you how to do the stress analysis of a beam on Ansys Workbench. So I hope you will have a good time, and then I will try to show you all the necessary steps in detail and also briefly. So don't forget to subscribe my channel and let's get started. So whenever you think of doing the stress analysis on a beam, the first thing that you just need to do is you have to construct the 3D model of the beam. So in order to do that, or in order to construct the geometry, you can use the Ansys Workbench itself, or you can use any other 3D modeling softwares. So for today, let us use CATIA V5, which is one of the modeling softwares in the engineering aspect, which is commonly used. So to create the geometry using this CATIA V5, just go to the start, and then the workspace look like this. So whenever you open your CATIA software, you will get such a workspace. And now in order to go to the sketch workspace, go to start and press it, and then go to mechanical design and click on part design. And then over here you can give the name that you want for your geometry, or you can leave by default like this. So let's leave it as it is. Now the workspace for the geometry creation look like this. So over here you can select any plane that you just wanted. So let us select the YZ plane and click on the sketch button. So now I just wanted the beam of the cross section to be rectangular. So just press the rectangle over here and then draw the rectangle starting from the center. Now, once you just draw the rectangle, you have to give a dimension for it. So let's make it 50 by 50. So go to the dimension over here and double click on it and select this side, as well as just select this side too. Now, in order to modify the magnitude of the dimension, just double click on the dimension. As you can see, you will get the constraint definition over here. So you can give the value for the respective side as you want. So let's make it 50. And again, let's make this side 50. Now we just make our rectangle 50 by 50. Now we just I just wanted to give it a depth. So for that, just exit from the workbench using this and just press on the pad in order to create the 3D object from the two-dimensional drawing. So just click on pad, and then over here you will get the pad definition, and then you have to give the dimension over here. Let's make it 400 millimeter. Now our beam is constructed, so you can import this to the workbench, to Ansys workbench, and then we can conduct this stress analysis on this respective beam. And then one crucial thing that you have to know is that whenever you just want to import any geometry to Ansys Workbench, which is actually created in other 3D modeling softwares, you have to save this actually 3D object in IGS format. So to do that, just go to File, and then just click on Save As. And over here, you can let's give the file name as let's rename it as a beam. And then look, you have to be careful about the just over here. Look, the type has to be IGS, because in order to make this respective geometry compatible with the Ansys Workbench, or in order for the Ansys software to read this respective geometry, it has to be saved in IGS format. And so don't forget to just select the type in IGS and save it. Now our geometry is saved, so you can leave this, and then we can open the Ansys workbench, and then it's already been opened. So the workspace of the Ansys software look like this. So from this, go to the analysis system, and then select the structural or static structural, this one, and then drag it to the project schematic. So now just go to geometry and then right click on it and let us import our geometry. So yeah, over here I just get BeamIGS. You have to go to the folder where you just saved your geometry. So I already get it, BeamIGS, so I will open it. And now the geometry has already been imported. So the next step that you have to do is you have to open the model section. So right click on it and just click on edit. So it's gonna take a few seconds to open, so you have to wait. So as you can see, the model workspace is already opened, and then our beam is now. You can go to geometry over here, and then if I just click on geometry, or if I just click on the beam over here, so on this box, look, all the basic information about the respective beam is given over here. It said the stiffness behavior is flexible, actually, which means that whenever you just if you just apply a load on the beam, it will deform actually. So if you want to make it rigid, so just click on it and then you can select the rigid part. And one of the basic important thing over here is that over here the material assignment is given as a structural steel. That means that this respective beam is actually made of the structural steel. So this respective material is actually assigned by default by the software. So if you want to change the material which your beam is made of, you have to click over here and then you have to just click on the arrow, and then over here you can put, or you can type the material that you just wanted. For instance, if you want your beam to be made of aluminum, just type aluminum. So let me select the first one. Now as you can see, previously it was the material was assigned as a structural steel. Now you just change it to aluminum alloy. And now look, if you just wanted to see the property of the material that you selected, just go to the material over here, click on the plus icon and go to aluminum alloy. And over here, look, the property of the aluminum alloy is given. So you can see over here that the tensile ultimate strength is 310 megapascal, the tensile yield strength is 280 megapascal, and so forth. So you can take the property of your material from this section. So once you just assign the material that you just wanted, the next step is you have to mesh the geometry to conduct the analysis. So to conduct the mesh, just click on mesh, and then over here you just the element size of the mesh is set by default, so you can give the dimension for the mesh. So let us make it 5 millimeter. And now after you just set 5 millimeter, so after that right click on mesh and just click on generate mesh. Now as you can see, the mesh is already been generated. So the next step is that we have to apply the boundary condition on the respective beam. So to do that, just go to static structure over here. So right click on it and then just let us give a support for the geometry. So for the support, let us assume that our beam is supported on both ends. So to do that, I have to select the face. So let us select this face and the face on the other end. This face, just hold the control button and select this, and over here just say apply. And then as you can see, the two faces are selected, so the two faces are actually fixed support. And the next step is I just wanted to apply a load on the beam, and then I just wanted the load to be applied vertically in the downward direction. So to do that, again go to the structural, static structural, go to insert and select force. And now I just wanted my force to be applied vertically on the downward direction, which is actually, if you just look at the axis, I just wanted the load to be applied in the negative y direction, which is vertically in the downward direction. So to do that, you have to select the face first. So let me select this face and click on apply. And then over here, in order to simply select, or in order to simply apply the load, just it's better for you to change the vector into component. So as you can see, XYZ component is given. as I said, I just wanted the load to be applied in the negative direction, which is negative, and then let me make the magnitude of the force 1000. So now the load has been applied, and then as you can see, it is in the negative y direction. So that's what I wanted. So the next step is you have to assign the parameters that you just wanted, or assign the required parameters. So I just want to know the total deformation. So go to deformation and click on total. I just wanted to know the strain equivalent to bone misses strain, and then I just wanted to know the stress too. Stress bone misses stress. So I just input all the required parameters that I just wanted. So right click on it, on solution, and click on solve. Now the analysis will be carried out and then it will be solved. So it's gonna take a few seconds. So it's around 53%. So now the calculation is completed. As you can see, all the solutions are completed. So if I go to total deformation, as you can see, it will give me the total deformation of the beam, and then as you can see from the diagram over here, there will be maximum deformation at the middle of the beam, which is given by the red color over here. And then if you just want to know the value, you have to go to the on the right side over here. So the red one shows the maximum deformation, and then its magnitude is given over here. It's around 0.0053 millimeter. The unit is given over here. So that is the maximum deformation which is experienced by the beam. And then if you want to know the equivalent elastic strain again, go to the equivalent elastic strain, and then as you can see, the equivalent elastic strain is maximum near the support, and then its dimension is given over here. It's around 3.5 times 10 raised to -5. As you know, the strain it's unitless, but the maximum strain is at the or near the fixed support. And then you can also know the equivalent stress. So as you can see, the equivalent bonus stress it's maximum near the support, and then its value is around 2.5 to 8 megapascal, which is given over here. So if I want to know the safety factor, or the factor of safety of this respective beam, you have to go to solution, and then you have to go to insert, and just click on stress tool, or maximum equivalent stress. If you press on the plus button on the stress tool, you can see here it just gives you the safety factor. So just right click on the solution and solve it. Now as you can see, the safety factor is around 50, which is actually very high. The beam is actually able to withstand the applied load, which is 1000 Newton. So finally, by just following all these steps, you can do the stress analysis of a beam or any structure. So this is all for today. See you on other videos. Don't forget to subscribe my channel. Thank you for watching. Bye bye.